In this video, we're going over the procedure for Lab 7, which is titled Phet Molarity Activity. The experimental procedure for this lab is composed of 4 parts. Part A is an introduction of the different components of the lab simulation. In Part B, you're going to see the effects of changing the amount of solute and solvent. On Part C, you're going to be predicting the concentration of a diluted solution, which includes just some word problems in which you're going to be doing calculations, and then you're going to be using the simulation to see if your calculations correspond to what the simulation is illustrating. Lastly, on Part D is some word problems. It's extra practice on dilution problems, but understand that for Part D, you're not using the simulation. You're just using these problems to practice on paper. In this video, I'm only illustrating Part A and Part B. For Part A, understand that there are 2 different links on page 3 of your lab sheet that can get you to the following screen, which is the simulation for this week's lab. In the different parts that we have for the simulation, they include, starting from the top left corner, a faucet that when you open it, it increases the volume of your solvent up to 1 liter. We have in the bottom of that a container that you can see has some markings of volume that go from 0.1 all the way to 1 liter. And you can see that specifically we have the markings for the 1 liter and the ½ liter mark. To the right of that faucet, we have a shaker that is going to present the different types of solutes that we're going to be using. At first, we are going to start with the drink mix. You can change those solid solutes by going to the drop-down menu and then clicking on them. As you can see, as you click, the chemical formula for the chemicals shows up in the shaker, and they're different colors for those solutes. I'm going to now change it back to the drink mix. We also have in the bottom of the menu for the solutes, our concentration probe. So when you move it towards the container, you can see how it's going to give you the concentration of this liquid or the solution once you start with the simulation in units of moles per liter. There are 2 ways in which we can decrease the volume of the solution. One is by opening the faucet that it is directly attached to our container. The other way in which we can reduce the volume of the solution is by evaporation of our solvent. And you can see here that we have in the bottom of the container an evaporation slide bar that when we move it from left to right, we can reduce the volume of our solvent inside of the solution. Understand that opening the faucet attached to the container or utilizing the evaporation slides, as you're going to see in this lab, have different effects on the overall solution. So to get started, now we are going to move on to Part B of the lab, which is where we are going to explore the effects of changing the amount of solute and solvent. On number 1, which is on page 4 of your lab sheet, it says to press the reset button, which is this orange button that we have in the corner. And when we press on it, you can see that the lab simulation restores to its original settings. For Part B, we are going to be working with the drink mix. And on the statement of number 1, we need to shake the drink mix shaker 3 times so that the solid particles go into the water. Let's start by doing that. We're gonna shake once, shake twice, shake 3 times. As you can see here, the first question, letter A, is the solute is the drink mix. The solvent is water. And understand that you have questions from letter A on page 4 to letter L on page 5. Let's continue. Letter B says, what unit of concentration in the meter probe is measuring? As I illustrated a few moments, is in moles per liter. Now, when I take this probe and I put it in the solution, you can see that at start, with the 3 times that I was shaking the drink mix, the concentration of the solution when the volume is half a liter is at 0.840. On letter C, it says add more solute by shaking the drink mix shaker. And then you need to answer what happens to the concentration when more solute is added. So as we add more drink mix, you can see that the concentration of our solution is increasing because we haven't changed the volume of the solution. It's still at half a liter. On letter D, it asks what happens to the color of the solution when more solute is added. You just observed that when I added more solute, the concentration increased. Letter E asks, what is the relationship between the concentration and color of the solution? And the relationship that those two have is that the deeper the color of the solution, the more concentration we have. And we can even see it in the numbers. We started about 0.84, and now we are at 2.710. On page 5, letter F, it says, add more water by pulling on the faucet to hold it open until it fills to the top. When we did this, remember that we increased the volume of the solution by adding more solvent. Then on letter F, it asks what happens to the concentration when more water is added. And if we compare it to the original concentration that we had before adding the water, which was about 2.7, I believe, now it is at 1.355. So the concentration decreased. On letter G, it says remove water to the original volume of half, quote unquote, using the evaporation slide bar. The evaporation rate depends on how far you slide the bar. Then you need to answer the questions. What happens to the concentration when the amount of water is decreased to its original volume? And then we're going to explain why this happens. So you can observe right now that at 1 liter, with the amount of drink mix that I already added to my container, the concentration is 1.355. Now, when I evaporate the solvent, meaning that I'm going to take that water from liquid form to gas form, and remember that this is done by increasing the temperature, I'm going to now evaporate some of that solvent all the way to half. Let's see what happens to the concentration. We can observe 2 things. Again, this is not a perfect system. 2 of the things that we can observe is that the volume of the solution decreased overall because now we have less solvent. We can observe that the color of the solution gets darker. And when we look at our concentration, we can see that it increased from that 1.355 all the way now to 2.742. When it asks, explain why this happens, remember that via evaporation, what we're doing is that we are reducing the amount of solvent. Reducing the amount of solvent results in reducing the volume of the solution. But because we haven't done any changes on the solute that was added to our container, overall what we see is that we are increasing the concentration of our solution. This takes us in turn to letter H, that it asks, assuming that the amount of solute doesn't change, which is what I was just explaining, what is the relationship between volume and concentration of the solution? Remember that when we added the water, what we were doing is diluting our original solution. Now, because in this moment, we are not changing the amount of solute, reducing the volume by evaporation of the solvent now is reducing the volume of overall of our solution. And since our solute is constant, just because we are not removing any solute, then that means that we have a more concentrated solution. Then on letter I, it says, add more solute by shaking the drink mix until the simulation says saturated. I'm just going to move the probe a little bit more. I'm going to move this drink mix. So again, we are at around half a liter. Our concentration is 2.7. Now I'm going to add more solute to the solution until it's saturated. So the concentration is increasing, increasing, increasing. We see that the color gets darker. And look, there is a message inside of our container. It says saturated. And it doesn't matter if I continue to add drink mix, the concentration remains at 5.960 moles per liter. So you can see here that even if we add more solute by shaking the drink mix, the concentration once your solution is saturated remains the same at its new concentration once the solution achieved to be saturated. On letter J, it says, now add more water until it fills to the top. What happens to the concentration? Is the solution still saturated? Let's observe what happens. When I open the faucet, as you can see, now the solution is not saturated any longer, and my concentration is actually reduced from that 5.9. Now it is about 4.995 moles per liter. So we even had a reduction in the concentration of the solution. On K, it says, look up the chemistry definition for saturated, unsaturated, and supersaturated. In the first video for this lab, you can observe the definition for these three different types of solutions. Then it says, based on what you've learned, explain why adding more water takes away the saturation sign from the simulation. Remember that if we add more solvent, we increase the volume of our solution. And if we have a saturated solution, adding more solvent, what is going to create is now that solute is going to be interacting with that solvent, and increasing the solvent results in now a decrease in the concentration. So you are not at saturated conditions anymore because the solvent volume has increased. Lastly, on letter L, it says, based on what you've observed, what is the relationship between adding more water to a solution and concentration of the solution? So through this exercise, you hopefully have seen that increasing more water to a solution, it decreases the concentration of the solution because you are increasing the amount of solvent, but increasing the amount of solvent overall increases the volume of the solution. And what that results in is the decrease in the concentration. Please revise the molarity equation in order to understand how these changes actually affect the unit of concentration, which is molar. In part C, remember that you will be predicting the concentration of a diluted solution. And you can see here that what we're going to be doing is that instead of working with drink mix, let me just click reset. You will be working specifically with nickel 2 chloride, which is this chemical right here, which is in green. So that's for part C of your lab. You are then going to be going through the different parts that are prompted on page 5 and page 6, and you will be doing some calculations, and the simulation is going to illustrate how those calculations that you do are correlated to the simulation. Remember that part D is just more practice problems for dilution problems.